Good day. Let's look at the problem statement for the first problem. So we have an array of integers and we're given a target. We have to find the indices of two numbers such that they add up to target. We assume that there's only one solution and we have a bunch of inputs. So let's start looking at this problem. So let's look at the input array. Now, one of the easiest way to solve this problem is just take this input array as given. We have a target of 9. The easiest and the standard brute force solution would be, let's say you choose 2 as input. You say that one of the elements that we need to select is 2. Once you select 2, you check with every other element. Okay, so 2 plus 7 kind of gives us 9. So that kind of gives us the answer. Now, let's say 7 didn't work out, we try with 11 and 15. Since we are given that there is exactly one solution, we don't have to look forward. So we can kind of summarize this uh, approach in two steps. The first step is choose an element and then go through the remaining elements to find the possible answer for the next element or the possible values for the next element. This is a standard brute force solution. Now, in this case, we got it on the very first iteration. Now, let us assume that the array that was given to us in the reverse order. Uh, that is, sorry, you had the input array in the opposite order, and the target was still 9. So, what would have happened in that case with this approach? So, let's say 15, 11, 7, and 9. 7 and 2, sorry, and the target being 9. Now, if you look at this case, this approach wouldn't work. You'd start with 15, you try with 11, you try with 7, you try with 2, nothing would work out. So then you have to go to the next element, try with 11, 7 and 2 don't work out. Then you try with 7 and 2 works out, and we get the answer. So this probably isn't the most optimal solution. Let's try to code this solution up and then we'll try to optimize it. So going to the code. So let's come up with the code in Java. The first step is, as we discussed, selecting the element, the first element, and then find the match for this element by going through the remaining of the array. Just going to get the total list of all elements. Now, as we've seen in the second example, we're going to have to check for all the values in the array. We can't just look at one value. We'll have to look at all of the values. So I'm going to get the number of elements in the array. I'm going to call it n. And from here, I'll have an outer for loop that will choose the first element. And post this, I'll have the inner for loop where we choose the second element and we check if their sum is equal to target. pretty straightforward. Let me just if it is equal to target, all I have to do is create a 2D array and return the two indexes. Sorry, an array with two elements, not a 2D array. And in the problem statement, we're told we can return them in any order. I'm just returning them in the order of I and j. And given the problem conditions, we shouldn't have a scenario where, we come out of the for loop with no result. But if we do come out, that means there is no solution. So let's test this code. There's a typo there. Let me correct that. It should be I plus one. Whoops. Yeah, let's give this a go. And looks like it worked. And you can see it's going to be look very similar in C code as well. In the input, we already have the size of the array, so we can reuse that from the input. And rest of the logic is going to look very similar. The only part that's different is we're going to have to use malloc uh, to assign memory to the result array. As you can see, the code also looks very similar. Let me just type it out. Now in C, we have to specify the return size as the pointer to the return size is given. So once we find the result, we are going to have to set the size of the result. And for that, we can just use the input pointer that's been shared as part of the problem. Now just malloc the result array and assign its values. Similar to the previous case, and return the result. In case we don't find any elements, we just set the return size equal to 0 and return an empty or return none. Let's try this. Oops, yeah, the two should be outside. Messed up outside the braces there. Yeah, yeah, this one looks okay. As you can see, this works now. In Python, it's going to look very, very similar. We get the length. So you can see that the approach looks very similar in all three languages. In Python, obviously, we have the range function in order to iterate for a range, but essentially the code is very, very similar. And yeah, just working it out. And in Python, we're just going to create a list and append elements to the list. Just return result. And if we don't find anything, we just return none. And this should work. Ah, sorry, it shouldn't be int. Python has auto data type. And yeah, you can see. Now, let's try to make it a little smarter. Now, if you look at this approach, what we're doing is we are iterating through the array multiple times. And because of this, we are not doing things in the most efficient way possible. Because of this, our time complexity turns out to be O of n squared because we're iterating the elements multiple times. And the worst case is the example that we have above. So let's say 7 and 2 for the target 9 are 1 and 2, it works out very well for us. If they're the last two elements in the array, then it's the worst case. So in order to reduce the time complexity, there are, in general, if you're going to reduce from n squared to something slightly better, we have two approaches. One approach is sorting, but that won't work in this case because we're looking for indexes. The other approach is let's store the values that we've seen and the indexes that we've seen them in. And what we can do is use a map that stores the value at the place and the index where we've seen it and reduce the time complexity to O of n, but we will increase the space complexity to O of n. Now, what this will do is improve the time complexity. We will uh, we will have greater space complexity, but what this does is kind of improves the performance. So what we'll do is we'll store the key and value in a map and check if we have the element that we need in the map. If we have the element that we need, uh, we can go right ahead and find return the result. If we don't find the element that we need, in those cases, we can just add things to the map and continue till we, iterate through the array once. If no such element exists, given the problem condition, we shouldn't run into this issue. But let's say we do, uh, then we can just return an empty thing. So let's consider the worst case example. Now, in this case, what we'll do is we'll take uh, 15, sorry, let's just take 5 and look at the indexes here. So you have 0, you have 1, you have 2 and 3, and let's store them in a map. So for 5, let's say the index is at 0. For 11, the index is at 1. For 7, the index is at 2. And what we'll do is we'll read 5. We'll see, the, okay, to get a target of 9, let's say you subtract 9 from 5, you get 4. Is 4 present in the map? Not really. We move again. We check. You subtract 9 and 11. Sorry. Yeah, subtract 5. Yeah. Is minus 2 present in the map? No, no, it isn't. Then 9 minus 7. Is it present in the map? So far, not yet. You don't see 2 in the map yet. Then what do? You get 2. You check if 9 minus 2, 7, is it present in the map? Yes, it is present in the map. In that case, you return it. Now, if you've noticed, we've only traversed the array one time. We haven't visited the array multiple times. Now, it's clear how we've reduced the time complexity from O of n squared to O of n, because we're only traversing the array once. And the reason why we are able to do it is we're storing these values in a data structure, in a map. So let's go for the more optimal approach in Java. Let's store the values in a map. Let's call it index map. Going to use hash map from Java for this. We should probably have the size of the array as well. Yeah, let's get the size of the array. Let's just check if the map contains key of target minus numzi. If it does, then that's what we need to return. If it doesn't, we continue. So let's create a new array. We get this value from the map, and the next one is just I. And in case we don't have the target, we just put this value to the map. Okay, so just add the values to the index map. And in this case, all we do is, yeah, if we don't find anything, we return null. So let's test the code. Ah, we forgot to, oh, we were returning it at the wrong level. Let me correct that. Let's try again. We are returning null. Okay, we're not returning res. Let me just fix that. And yeah, just return res. Now it should be good. And yeah, works. Cool. Now let's look at the same thing in C. This is going to be slightly more challenging in C. C does have a hash table, which is very similar to hash map, but you're going to have to write your own add and find function. So let's write the add function first. Before we write the add function, we've got to figure out how we're going to store the data. So we've got to define our custom data structure. So I'm just creating a structure called data, which has value, which is the value on the array, and then I'm going to store the index. Now we are going to look up the hash map based on value. So this is going to be the key in the hash map or hash table. We're going to have to use the hashing function as well. Yeah. And in order for us to hash, we'll need the predefined macro. And this is the hash macro. By convention, we call it HH, and this is the struct. Let's define our global. data structure. So this will be our map, and let's just assign it to null. We'll add values to it when we in our add function. So let's start with that. Let's add a value and a index, and let's do that. Let's create a new struct. We're going to have to malloc some memory and then uh, assign the values. Let's call it entry. So ideally, you'd want to check if the value is already present in the hash table. But for our case, we're told that there's only one solution. So we can directly malloc uh, or assign memory to store this. And let's just malloc it. Size of struct data. Yeah. Once you have the entry, assign the values to the appropriate variables. Let's assign, uh, entry value equal to value and entry arrow index equal to index. And there is a function that we have, hash int add, and let's just reuse the, sorry, we have a macro and let's just reuse the macro. And yeah, the arguments here are the pointer to the actual variable, the name of the key inside the struct, in our case that's value, and the actual pointer to the memory that needs to be inserted. So we're inserting memory. Now let's write the find function or contains key. Let's just call it contains key just to make it similar to the name that we had in Java. So let's send a val and let's search for this value in the hash table. Ooh, hash table, sorry. So the name of the data structure in C is hash table, not hash map. Yeah, let's call it contains. Yeah. Let's get a pointer, and what we can do is we have a function called hash find. We're using int because the key is of type int. We send the value, the pointer, yes, and then we return the result pointer. Cool, this should be good enough. And then what we do is very similar to what we've done before. So we'll iterate through the array and we'll essentially do what we did in Java again. Copy the variable name. I'm just going to check if the value is already present in the, yeah, let's just call it P. Just check contains value, and I'm just going to pass target minus thumb size, similar to what we did in Java. If this value is null, then we haven't found it. But if it's not equal to null, we have an answer. So we can just malloc a result array and return it if this structure is not null. So let's just do that. Um, yeah, we create a pointer, malloc the memory, and now let's just for the zeroth index, let's just use the value in P. Let's use the value there, and for the first index, let's just use I. Uh, okay, let's just rename it to RES. We've always used RES, so it makes sense to just use RES again. Let's just return RES from here. And in the other case, if we don't, if it's equal to null, we just add the entries to the hash table. We have to set the size of the return size to 2 in case we have a result, and in case we don't have a result, we can just set it equal to 0 and return an empty or return null. Okay, so let's try this. Ah, okay, so when we find, we have to actually give the value, the address of the key that we're looking for. Let me just use ampersand val. That should resolve this. Okay. Cool, let's try this. Ooh, okay, what went wrong? This is okay, this is interesting. Let's just look at what we have in the hash table. Yeah, so if we ever want to print values in the hash table, let's just, yeah, it shouldn't be that complicated. Something seems fishy here. Yeah, so just to check if the hash table is working properly or not, just checking this. So let me just create a new variable here, assign it to the global map, and just iterate through it while res or res shouldn't be null. And internally, this is basically a linked list, and we just use uh, hh.next to get the next entry. Right. hh.next returns a type of void pointer, so we have to cast it. So yeah, dot result arrow hh.next next. So hh is the hash function we've defined in the struct, and yeah, so I'm just going to print the values here. Something's weird. Yeah. So looking at the hash table, we'll get an idea. Yeah, let's check the index. Um, it's interesting. It's working for two cases. It isn't. Something fishy is going on. Yeah, let's just keep everything on a new line so that we're clear. Let's try this again. Let's call the function the moment we print the value. Okay, let this go. Let it rip. We're using values from previous iteration. Okay, makes sense. We just have to set map equal to null here. That will take care of it. Yeah, so we were using values from previous use cases that was causing the concern. Yep, let's just comment out this, fire this. We probably don't need to have the print hash table function here as well. Yeah, let's just go there and comment the unnecessary part out. And yeah, let's submit this again. Should be a little better. And yeah, You can see that there's a slight improvement when you get rid of the unused function. And the Python code. In the Python code, we're going to use a dictionary, and the dictionary is going to basically do the same thing. Just get the length of the list and then iterate through the list, use the dictionary. Very similar to what we've done so far, but the syntax looks different in each language. I'm going to call it map just to keep it consistent. If target minus numsci in map, oops, we find it, we just create an empty list, we append, yeah, sorry, yeah, append I and return result. If it isn't present, simply add it to the dictionary. If we come out of the loop, just return it, and if it isn't present, just add it to the dictionary, and we should be grand. Equal to I. This should work here, and yeah. So yeah, that's how you can solve this problem, and this is probably the most efficient solution. Thanks so much for your time. Have a lovely day.